for problems like number 9, you should have these 4 series memorized. The first 4 or so terms, what the series is in summation notation, and what the intervals of convergence are. Alright, so if you know these pretty well, and especially if you have them in front of you, then we can evaluate exactly what each of these converging infinite series are equal to. First, I would ignore these constant values, like 4 and 2 and 3, and focus instead on the part of the denominator with n's in it. Here we have just n in the denominator. Do any of these fundamental series have just n in the denominator? This one. What about just n factorial in the denominator? No, no, no. This one. And what about 2n plus 1 factorial in the denominator? Just this one. Well, what about the rest of the expression? For the green one, we had negative 1 to the n minus 1. Same thing. For the purple one, there's nothing else except for the x. Ignore that for a second. And for the blue one, there's just the alternating part, and that does match. So again, for the green ones, the negative ones matched. For the blue ones, the negative 1 to the n matched. And all that's left is that weird constant 4, and that weird constant 2, and that weird constant 3. Well, all of these we've got an x remaining. So somehow that constant part is going to be related to the x. If this is the series, what value could we raise to the nth so that we'd end up getting 1 over 2 to the n? If x was 1/2, 1/2 to the n power is equivalent to 1 over 2 to the n power. What about in this case? We're looking at the series for sine of x. What x value can we substitute in for x so that it would end up being equivalent to 1 over 3 to the 2n plus 1? What can we raise to the 2n plus 1 power? So that's the same as 1 over that. And that one is, if x is 1/3. If x was 1/3, 1/3 raised to this power is the same thing as 1 over 3 raised to that power. And finally, let's come over here and ask, this is the green function, which is the series for the natural log of x. What x value could we put in so that x minus 1 to the nth is equal to 1 over 4 to the n? And that would be when x is 5/4. Because if x was 5/4 in the series for the natural log of x, 5/4 minus 1 is 5/4 minus 4/4, which is 1/4. And 1/4 to the n is equivalent to 1 over 4 to the n. So that's when x is 5/4. So if this series is equivalent to the series for the natural log of x, and this series is this series when x is 5/4, and that means this series is equal to the natural log of 5/4. Final answer. That's what that series is equal to. And for part B, this is the series for e to the x. And if we use this series for e to the x and substitute x equals 1/2, we get exactly what we're looking at. So this series is exactly equal to e raised to the 1/2 power, or the square root of e. And finally, on this one, if x is 1/3 in the series for the sine of x, 1/3 to that gives us this part. It's basically exactly the series when x is 1/3. So this series is exactly equal to sine of 1/3. And that concludes the video explanations for test on sections 9.6 through 9.10.